Hello everyone, I hope everything is going well. Today we will be discussing the binary search algorithm. Binary search is one of the most used searching algorithms. Therefore, in an interview, you may be asked to apply binary search directly, or you may be presented with a challenging topic that employs binary search. So let's get started by giving an example of how you're going to use binary search. So we have a list of numbers that are sorted because that's one of the conditions to implement binary search. So the list that you're going to be implemented on it, binary search must be sorted. If it's not sorted, you can't implement binary search. So remember guys, the list must be sorted if you want to implement binary search algorithm. So we have an array or list and we have a target number and we want to find the target inside the list using binary search algorithm. So how does it work? The first thing we're going to do is that we will determine the number in the middle of the array. Then based on this number, we will continue looking for the target and either the left half or the right half of the list or the array. So to find the middle number, we're gonna declare or initialize a left pointer and a right pointer. The left pointer gonna be pointing to the first number inside the list, and the right pointer gonna be pointing to the last number inside the list. And so to calculate the middle number, we're gonna sum up the left pointer index and the right pointer index and divide them by 2. For this example, it's gonna be 0 plus 7 divided by 2, and we'll make sure that the result gonna be an integer, not a float numbers. Means we don't take a number with decimal. So the middle number at index 3 are 11. And now we compare the middle number to the target value. If it's equal to the target, we return true. If we're not, we continue exploring. So is 8 greater than 11? No. Means all the number at the right half are greater than 8. So we eliminate the right half and we move to the right pointer to point to the index before the middle, means middle index minus 1. And now we can start again the calculation. We're gonna say the middle gonna be 0 plus 2 divided by 2, which is 1. So the mid number, it's the number at index 1, which is 4. And we compare the target number 8 to the middle number, which is 4. Is 8 greater than 4? Yes, so we eliminate the left half because every number to the left is smaller than 8. So we repeat the same process. We move the left pointer one position after the middle pointer, and now we have the left and the right pointing to the same number. Means that the middle gonna be the same number because left plus right divided by 2, it's gonna be equal to 2, the same index. So the middle number it's at index 2, and now we compare the target to the middle number is 8 equal to 8. Yes, and finally we find the target value and we return true or we return the index of the value. And that's how we implement binary search algorithm. For the code explanation for the recursive solution, the first thing we're going to do is to declare a function that takes a list of numbers and a target number. After that, we're going to declare a helper function that's going to keep track of the left pointer and the right pointer, and it's going to return the result. For the base case, we're going to check if the left is greater than the right. If it's true, we return false. After that, we start calculating the middle, left plus right divided by 2. And we initialize a variable that's going to be equal to the number of the middle index. We start comparing the target to the middle value. If it's equal, we return the middle index, mean that we have. If it's larger than the middle, we return the binary search helper function with changing the left pointer to the next index after the middle value equal to middle plus 1. Else, if it's smaller, we return a function with changing the right pointer to the previous index before the middle, means middle minus 1. So for the iterative solution, we're going to create a while loop that's going to compare the left and the right pointer. And we start comparing the middle to the target. If it's equal, return the middle index. If it's larger, we move the left pointer to the next index after the middle. If it's smaller, we move the right pointer to the previous index before the middle. And if we don't find the target, we return false. For the time complexity is gonna be O of log n, where n is the length of the list. And the reason why it's O of log n is because we're eliminating the half of the list each time we traverse the list. For the space complexity is gonna be O of 1, but if you are implemented binary search recursively, it's gonna be O of log n because you are using frames inside the call stack.